Hello, everyone. Welcome to the fourth part of the IP Fundamentals for Pro AV Professionals webinar series. My name is Tibor Fejes, and I will be the host for this event. I will be staying in the background, monitoring the session and looking out for your questions. And as in the previous 3 episodes, our presenter is going to be Gábor Kocsis, our technical trainer. You can also see his webcam. While we wait for some more attendees to join, I'll go through my usual routine of discussing the housekeeping items or the technical details. First of all, depending on what type of device you're using, you will be able to see Gábor's webcam and his shared screen. Today, you will probably look more at his shared screen rather than his webcam because he will have some live demonstrations and configuring switches. So you can manually resize one or the other to see it better, depending on which one you want to look at in more detail. Secondly, since this is a webinar and we can have hundreds of attendees, all attendees are muted by default and you don't have the right to unmute yourself. But you can send your comments or feedback or questions using the questions panel. So you can see a question mark. You can tap on that or click on that, and then you can send your question during the webinar. As in the previous episodes, we will probably see questions at the end. Most people are just looking at the display and trying to understand what Gábor is talking about, but that's okay. We usually have questions at the end. We will keep the interesting questions until the end if we have any during the session, and I will read those questions out loud to Gábor, and Gábor is going to answer those. And lastly, I would like to assure everybody that this webinar is being recorded, and GoToWebinar will send you an automatic follow-up email 2 hours after the session ends, and that email should contain the link to the video recording. If it doesn't, it happens with GoToWebinar sometimes that the link is not in the email. It wasn't in the morning session, but there is a recording, and if you would like to watch the recording again, please let us know, and we will send you the link to the recording. And the recording will stay on GoToWebinar server indefinitely until we see this content being relevant and up to date. If we make a new version, then of course we will delete this recording and make a new webinar, but you will be able to watch that one. So I think if people were a few minutes late, they're already here. So let's jump right into the fourth part of this webinar series. Gábor, the stage is yours.
Thank you, Tibor. Hello, everybody. So as Tibor mentioned, today in this session 4, we're going to look into the Wings product portfolio's communication, and we're going to see how to configure the network devices. And so it's going to be a kind of a configuration tutorial. This is not a marketing presentation, so we're going to talk about only those features that impact network communication and bandwidth. So we're not here to tell you what Wings can do. We're going to see how network communication goes. This is important. Now, a couple of things in the first 3 parts, we talked about Pro AV specific network details, and we'd like to kind of remember that we need to remember those features. One of them was, of course, multicasting, and the other thing is the VLAN functionality. And these things actually going to be demonstrated, and we're going to play around with these functions, and we see how the communication changes on the network when we enable or disable these functionalities. And what we're actually going to do also today is we will learn a few additional things that are AV specific and AV over IP specific. So I'm going to talk about the HDMI versus AV over IP bandwidth communication differences. I'm going to talk about something called the UDP or user datagram protocol. I'm going to compare it to TCP because we're going to see this kind of communication going on. I'm going to tell you about the jumbo frame functionality, which is important for Wings. And then we're going to look into a couple of small features in Wings, how to manage bandwidth situations with the specific compression and specific technologies. Now let's first look into a couple of general details that are AV over IP and AV specific. Some of these things actually you already know from previous trainings. You know, let's say if you have a 4K 60 RGB screen, then if we want to send this over an HDMI cable, then the active area on the video signal itself is approximately 12 gigabits per second in bandwidth. And of course, because of the audio and the other data information, we send the blanking area as well. So that adds approximately 19% on top of that. And because it's HDMI, we're going to put the TMDS on it. And the encoding also adds 25% on everything before that. And that's how 18 gigabits per second will be the network bandwidth that we're going to need, or the cable bandwidth we're going to need to deliver that signal. The difference in AV over IP is that we don't need the DMDS and the blanking. We're going to only make the 12 gigabits per second active video detail into packages, network packages. I'm going to put some headers on it. So we do an IP packetizing, and that's how we get a little under 13 gigabits per second. So it's a fairly small, under 8% extra data to create this whole video stream in AV over IP. Now, these numbers are important because today we're talking about a gigabit Ethernet communication. Now, the other thing is that how do we deliver these messages? And of course, it's a fair thing to ask what happens to the data that's in the blanking area. We're going to talk about that too. Now, the important thing for us in AV over IP business is the UDP communication, or user datagram protocol. This is actually one of the simplest communication in networks. But it is actually, it's very similar to like a letter in the post box. You put it in and it's gonna somehow travel through the network, and it will probably reach the destination. During the travel, nobody knows where it is. And if we are lucky and we get a response from the recipient of the letter and say, thank you for your postcard, then we know that it reached the destination. Now, typically a postcard or something like this has its content intact, so we have a meaning inside that letter. And we don't need multiple letters like letter 1, 2, 3, 4, 5 to send over to deliver the message. So this is actually why a UDP packet is standalone. So the content can be understood by itself. And because there are no multiple packages going on, there is no sequence number in it. So we don't have to make sure that the letters arrive in the correct order. And the other thing is, because of this, we don't actually need to trace and track where the package is. So we don't need a connection. Like we drop it in the post box, we don't actually talk to people, we just drop it in, and therefore we call it a connectionless communication. And because of this, we can actually use this communication to multicast and broadcast messages. And this is why it's perfect for the AV over IP. And this is actually compared to something we call TCP, or Transmission Control Protocol, which is something that you've known mostly from the internet downloads. When you download a large file, what happens is that you actually receive that in many small packages. And this technology actually has sequences, because if you have a large file, you have to put it together on the other end of the communication. So the network cards need to know which products or which packages to be put in what order to make the file whole again. So those pieces actually belong together in one package. And so we have a sequence number in every packet. What we also have is, because of this, we need to do some sort of a communication, and we need the recipient to confirm that the packages, the individual packages, were received. So it's like on the parcel service, when you have to sign for the package when you receive it. On the other end, of course, the person who sends it has to also sign for it. This is pretty much what goes on a TCP communication. And because of that, is actually a unicast communication. So this is going on between two computers and two IP addresses. Now, we use this actually for USB storage devices. Let's say in Vinx, when we connect to the KVM ports, we can actually deliver files. And today we're going to do that. Now, in the previous parts, we talked about different layers. So the layer 4 is the network layer, actually, when the transport layer and network layer. When we talk about these languages, so we talked about the comparison, and TCP and UDP are a form of description of how the communication goes. And that's kind of a language, when a language describes how a communication goes between humans. And this is actually what these two protocols do. So they describe exactly how the communication will flow. Now, there are, of course, a number of Vinx specific details, and we're going to go through them one by one to understand how it goes in this product portfolio. The first is, of course, we already know how in traditional AV, we have the stream of bits going on in the different colors, the 3 colors RGB, and of course we have the clock line as well. We have a constant stream of this bit information to deliver everything, the blanking area and active area as well. While in Vinx, because of the bandwidth needs and the demand from the market, we're only sending information what we need to send and when we need to send. So we're not going to send everything at the same time because the bandwidth is not sufficient for that. Now, of course, it's fair to ask, I previously asked, what happens to the other data? So We talked about network port numbers and different protocols in the previous parts of this training, and the port numbers actually identify different streams of communication. This is exactly what happens. So let's say the video signal is sent on one port number pair, the audio is sent on a different one, and for example, USB is sent. Now, what we're going to do today is I'm going to actually show you, we're going to create a graph like that. We're going to see that happening live, one by one. So you're going to see these little graphs changing. Now, another thing which we need to talk about is jumbo frames. Jumbo frames actually are a large packet, and typically when we send, let's say, standard packages, we have about 1,500 bytes, so 1.5 kilobytes data packets. And what happens is, if we want to send UDP streams or data video streams, then we actually have to somehow put those information together at the other end, and it's easier for us to actually send the visual information or the video signal in a larger packet. So with this, we'd like to save a little bit of more bandwidth. So what we do is with this jumbo frame, we use the same amount, approximately the same amount of data space, and we only need one header. So instead of sending 6 packets and using 6 different headers, we're only going to have one header space. And the rest 5 header spaces, that's 5 times 42 bytes in this particular example, will be saved and will be used for a data communication. This is actually quite important because of the bandwidth we use. Now, I gave you a little bit an example of how standard frames and the jumbo frames look like. If I send the same information in standard frames, I need a little over 2,200, almost 2,300 packets to deliver in about 300 milliseconds. So that was a Wings initial screen image. And I did the same thing with jumbo frames, where we need a little under 500 packages. So we have a lot less headers, and we are actually saving some bandwidth because we need that for data. Now, the important part of this actually is that because of the Wings products are designed for the gigabit Ethernet network, every bit actually counts. Now, because of this, we have additional features besides the jumbo frame and the way how we deliver the different information. We can actually change the maximum bandwidth we can utilize on the network. So let's say automatic bandwidth is default, so the device will use whatever bandwidth is available. We also can do, let's say, set it up to 100, 150, or 200 megabits per second, and we only consume that much on the line. This actually helps us if we have multiple devices communication going on the same cable. We do also have actually 10 and 50 megabits per second, but it's really rare a situation to use. It's a little too small for higher bandwidth communication. It's not really recommended, but I mentioned that it's actually possible. Now, the other functionality, of course, we have is we have to somehow take care of bandwidth loss situation, where for some reason our bandwidth is a little narrower than we expect. And what Wings does is it has 2 transmission modes. One is we call the graphical or a graphics mode. This is like when you deliver a computer screen and the details are important. Now, in that case, when every bit counts and every pixel is important, then it's easier for us and better for us if we drop a couple of frames and reduce the frame per second parameter to deliver the same signal, because that's not going to be that visible for the user that we dropped a couple of frames. Now, if we watch a movie and we turn it into movie mode, of course, the frame drop would be visible, so it will bother the viewer. So what we do is we can actually temporarily reduce the signal quality, and let's say there's some pixelation that's going to happen, and so we manage the bandwidth situation, but we're not going to drop frames, and the customer is not really going to notice a temporary short pixelation of the screen. This actually happens just because the bandwidth is lower than we needed. Now, it's important actually because in other products, which we're going to talk about next week, it's the UBEX product, we're not going to use this technology at all. We don't need it because a product with 10 to 20 gigabits per second trying to deliver 13 gigabits is not a problem. So we don't need this functionality. We have enough bandwidth to deliver a 4K 60 with 444, and technically we don't need any compression, and we can deliver every bit constantly and still have enough bandwidth. So none of these technologies are necessary and that's going to be a completely different situation. So next week we're going to look at the UBEX, but we're going to do a completely different approach because of certain things that are different in the product. Whatever you see today in the analysis is not going to be possible. I'm just going to mention that you're going to see a couple of tens of thousands of packages being delivered today. In the UBEX, we're talking about hundreds of thousands of packets. So there are certain limitations which will not make today's analysis method possible. But let's focus on today's subject. And in the previous part, in part 3, I actually mentioned a managed switch functionality called port mirroring or probe functionality. But this is actually needed because we have a network switch that is core job is to send packets between devices and not to send it to other devices that are not interested in that. So under normal circumstances, we would not see a communication between devices. However, IT managers and IT guys need to actually look into communication between devices. And so this functionality allows them to look into the communication and receive everything that goes on that port. I think I mentioned also in part 3 that this is so basic functionality that it's even in the basic configuration part of the network switches. Now, of course, it's important to know that if you use this feature on one port, no other network communication will be possible. It will only be just a probe or mirror port. This is actually what we're going to do to see exactly what's going on between the Wings products. And the side note that this actually can be a gigabit Ethernet port, SFP or SFP+. The only real requirement is if we are monitoring or mirroring a communication, then the probe port has to be at least the same speed or faster. If you would like to, let's say, mirror a SFP plus 10 gigabit communication with a gigabit Ethernet port, 90–95% of the packets would not be arriving to the computer. So that's why today we're going to actually use an SFP plus port to mirror and look into packets between 2 gigabit Ethernet ports. And one more thing is today's setup. So in today's physical setup, what you're going to see is in a couple of minutes, we're going to switch over to another computer, which is a HPZ4 workstation. This is connected to a Ubiquiti switch, and we have a pair of Wings products on it. What we're going to do is I'm going to connect my electric guitar that stands next to me, and I have a speaker at the desk, and we're going to actually see how audio signals are being delivered. And then I'm going to take a USB data storage device, which is right here on the desk. I'm going to put in the card, and we're going to deliver a file over the network with the over the Wings pair. And then I'm going to connect my laptop's HDMI signal, and we're going to have some video information going on. Now, when this actually happens, what we're going to also do is we're going to actually sniff or monitor that communication and record it with a software called Wireshark. And I'm going to actually show you a very nice and very simple way how to make that information easy to diagnose and analyze. So we're going to import it to Excel, and I'm going to show you how to look at exactly what's going on the network in a very nice and tangible way. So this is how the network setup is going to look like. And now let's switch over to the other computer. And I'd like to ask Tibor to switch the computers. And now you see my other workstation. So first, I'd like to mention that in the second part of this webinar series, I mentioned the documentation. If you go to our website and downloads and you go to the application note filter and you put in network, then you're going to be receiving that's actually you're going to filter down to 2 documents. And one of them is the Wings network switch guide. And if you download that, we're going to actually do step-by-step what this document describes to actually enable these features. Now, before we do that, I'd like to show you the user interface because I'm going to use a Ubiquiti switch today, which has actually 2 user interfaces. They simplified a new user interface, which is graphical, and there is the legacy mode. In the documentation that I showed is mostly legacy mode. But let's see first how our network looks like in a graphical way. We have actually a couple of ports enabled. In port 6, which is a SFP plus port, we are mirroring information going between the Wings encoder and the decoder. In port 13 and 14, we have the Wings pair. And on port 15, we have the network interface that is connecting and configuring these devices. So if you have a little bit of a network experience, you already see something wrong is going on here. It's because most of the features that I'm going to show you are turned off. So this is the first thing we're going to look into, a little bit of how the network communication goes. And I'm going to also show you another screen, which is the VLAN settings. Now in Ubiquiti, typically the switch comes with a factory default setting of every port being in the VLAN number 1. So you can configure the device from everywhere. And all of those ports are actually untagged VLANs. We're going to actually play around on this user interface a little bit. I'm just going to show you a side part with the MAC addresses and the IP addresses. So here are the 3 devices we actually have. So we're going to play around and we're going to fix the communication. Now, before we go into the network switch, I'm going to open the LDC software, and I'm going to show you that the moment I open this up, then I can see the 2 Wings products. I'm going to refresh the screen. So right now we are communicating with the devices, and that's actually because we are in the same VLAN functionality. Now, of course, there is something that we would like to play around, and we see. So what I'm going to do is I'm going to actually switch these 2 devices into a different VLAN. That's the first thing we're going to actually do and see how it affects us. So right now in the VLAN 1, we have the workstation and both the Wings devices. What I like to do is I'm going to put into the other 2 VLANs, the other VLAN number 2, and we'll see what happens with that. And that is because we have something wrong going on right now. In fact, what happens is the Wings encoder is sending some sort of messages of 46 kilobits per second. Same thing happens with the decoder. These are management things. But at the end, for some reason, this computer, my workstation, is receiving that. So I have over 100 kilobits per second data that I don't want. So, okay, let's fix it. Now, in the previous trainings, we talked about the VLAN setup. So what I'm going to do is I'm going to put these devices into VLAN 2. Now, we mentioned this a little bit, that you cannot have 2 network ports as untagged VLAN in 2 different VLANs or more untagged VLANs. The system says, wait a minute, something's wrong. So now I'm going to actually put it into VLAN 2, apply the changes, and we're going to see what happens. So now, very soon, we can see that our communication on the workstation gigabit Ethernet port is dropping. So I have actually no more of the communication of the Wings encoders. I have some other communication going on, but the 100 kilobits or 60 to 80 kilobits per second information is gone. So yeah, okay, I think I kind of fixed it. But let's see. If I go to the LDC and refresh it, then they are gone. This is what we mentioned in part 2 and part 3 a little bit, that if you use the VLAN separation, VLAN will not just get rid of the multicast messages, it will get rid of the broadcast and the unicast messages as well. The 2 VLANs are now completely separated, and I do not get any additional information or unnecessary information from the devices, but I also don't get what I need. I cannot see the devices. So, okay, so this is what VLAN does, but this is not something I need. So let's go and put it back to normal mode. Let's try to fix it somehow else. So I'm going to apply this, and we're going to go back and see what happened. And of course, the communication will go back again, and my workstation gets all those data again. So we're going to somehow fix this problem, because this isn't the right thing to do. Now, in order to do that, we're going to actually go into the user interface that is documented in the documentation and the manual I've shown you. And we're going to go into that interface. Now, and if you look at the interface, one of that documentation, actually the documentation mentions a feature called the jumbo frame. Let me show you how it's done. We go individually into each port, that user interface. And if I set it up, then the maximum frame size is, you see, 9,216, that's the maximum. So this port is enabled to be a jumbo frame functionality. And the same thing actually happens with the other port. And remember, this is a managed switch, so you can enable and disable all these features port by port. We have the same feature actually enabled on the other port as well. So, okay, now jumbo frames are enabled. And for a very specific reason, I do something that will make the analysis look nicer. I wanted to make sure that we understand what reality and what demonstration. The mirror port this port actually has over there, it says MTU size 1518, that is the standard frame. So for some reason, and I'm going to show you later why, the mirror port of this workstation is not enabled for jumbo frames. We're going to actually go through these details and we're going to see the analysis. Let me show you step by step what the documentation still says. We talked about the VLAN parameter. That's the next thing that the documentation say. And this is actually the same thing in this user interface. And the difference is because of this user interface, it recognizes that there is already the port in one VLAN is untagged. It does not even offer me the opportunity to put it in an untagged VLAN and give you an error message. This layer simply doesn't let you do that. So this is a general difference. Now, okay, so far the communication is fine, but we still have all this noise going on in the network. So I have this 126 kilobits per second. I don't need that. Now, if you continue with the documentation, it's going to talk about IGMP snooping. So I'm going to go to the IGMP snooping surface, and there are two actual options. One is we enable something called the admin mode, so it kind of enables it and allows to communicate that. And in order to have more time and not to spend 1 or 2 minutes setting up individual interfaces, I've already enabled the IGMP snooping. It's disabled right now, but in the interface configuration, I have actually enabled those. So port 13, 14, 15, and 16, the gigabit Ethernet ports in the switch are actually set up. So you can see the admin mode is enabled, 260, 10, 0, and the fast leave mode is enabled. So this is actually how these ports are set up, exactly how the documentation says it. However, of course, to see the differences, I did not enable the entire IGMP service. Let's do that. I'm going to enable it and I submit. In many cases in switches, it's recommended to save the configuration once you change something, and it's done now. And let's go back to this simple user interface and see what happens. So the communications seem to be dropping, and now we no longer receive that data. Okay, but let's verify that it's really true what I'm saying. So for a temporary option, I'm going to connect the video signal, and we'll see what happens. A couple of seconds, the Wings products actually start communicating. And now you see that 50 and now 97 megabits per second is going between the two devices, and I don't get unnecessary information in my workstation. Okay, that's the first thing. The other thing is I'm going to take this card and I'm going to put it into the reader, and in a couple of seconds, the computer is going to recognize that this device is right here. There we go. So now we've seen some communication going on. Of course, a file is not that big compared to the video signal. So we can see that the two Wings devices are communicating with each other, and I don't get all that unnecessary data on my workstation. Okay, but let's see what happened with the LDC software. Now, these were gone, but now I refresh it, and now the devices are here. We're in the same VLAN, and there's a reminder that I set them back to the same VLAN 1, so the workstation and the both Wings are in the same VLAN. So we see broadcast and unicast messages, but we don't see the multicast messages. So I can see the devices in the LDC software, but in the network switch, I do not get all that information. And that's why we didn't see all that messages coming through the workstation. Okay, so this is how we set it up, and now we see how this is impacted. But let's do the analysis. I promised to you we're gonna look into the communication between those devices, and we're going to do an Excel import. Now, before we do that, I'd like to show you something. This is a quick screen capture of a real video signal. The large green pylons are actual video signal, and these tiny little green ones are the audio signal. This is how it looks like in reality. This is how the scale is to video signal, 1080p video signal to audio channel. However, during this demonstration, this would not be nice to look at. So this is the reason why I turned off the jumbo frame option in the network switch for mirroring, which means when I'm going to demonstrate the audio signal, the file transfer, and the video signal is going to be a lot smaller. So And this is so you actually see the different communication. So if you notice that, wait a minute, how can 1080p be that small? It's really not. I'm just not letting the jumbo frame information be this high like it's on the screen. And so we can actually have a nice graphic to analyze. Okay, let's do that. Now let's do the screen and let's use the Wireshark application. I'm going to turn on the monitoring and I will actually look into the graphical interface. Okay, so what you see now in live is information going on. And we actually have like a 10 kilobyte information going between the two Wings devices. The maroon colors are TCP communication and the red is UDP. Okay, so let's see how the network communication goes with other different channels. I'm going to turn on the audio, and very soon actually you're going to hear the sound of an electric guitar down here. And I'm going to cycle through the device, and I'm going to turn it back to HDMI, which is not connected, and now the audio signal is gone. So those bars you've seen were actually UDP communication in specific channel would deliver this information. Now, the next thing, I'm going to take this card, I'm going to plug it in a couple of seconds. The computer says I have a communication, and you see those maroon or red bars jumping up. That's TCP. Okay, let's transfer a file. Let's take one of this, and let's say this is the documentation I mentioned, and let's copy it. Now, while I'm copying it, you see those tall red bars are going. Those are TCP communication going on, and now the file transfer is done. Okay, so we have two different type of signals. Let me disconnect the card. And let's see a video signal. And this is where you're going to see a smaller block. I'm going to turn on. This is how I connect it here. We're going to have some minor communication going, a little bit of green bars. I'm going to move the mouse so you see jumping bars a little bit taller, a little bit shorter. I'm going to let go of the mouse. It's going to go down slowly. So that's the video stream. And remember, they are tiny because if I would enable the jumbo frame, it would be huge and you would not see the other bars anymore. So this is how you look into a network communication. And this is what we're going to actually analyze. I go to the capture. I'm going to stop the capturing process. And now, since Wings has a very nice, the Wireshark has a very nice feature, I'm going to export it into comma-separated values. The classic extension, I'm calling it 123. Now, I'm going to open Excel, and I'm going to work a little bit slower than usual because of the GoToWebinar refresh rate. I'm going to go to the data part, or insert part first. And I'm going to go to import the text file. Let's see. So I have this text file in here, and this is 32,000 rows of data. Now, the real data is a little more, but the jumbo frames are not here, so not bother us with the video signal. Now, we have multiple columns. We have the time parameters, IP addresses, and so on. I'm going to select everything, and I'm going to actually now insert into a pivot table. Now, in pivot table, I actually prefer to do a couple of things. First, I don't like to have empty cells, so I put a 0 in here. And in the display mode, I prefer the old classic way of drag and drop. So I enable the classic view. Okay, so now we have a little table, and we have the columns. So let's take the protocol first and drop it in. Now we have a number of interesting protocol descriptions here. The ARP, IGMP, V2, and so on. A couple of interesting things. Of course, we have the TCP and UDP. Now, if you see, and if you have, when you have some more network experience, you might see protocols that are not supposed to be here. IGMP v3, for example, will indicate something strange. ICMP, Internet Control Management Protocol, will also indicate a possible issue. But let's talk about it a little bit later. Let's build this table and see what kind of data we have. This is length of packets in bytes. And this is when you can see the different protocols during this time when I was capturing. They sent quite a lot of TCP and quite a lot of UDP packets. If you look at that number, is almost 8 million bytes of UDP and 1.5 million bytes of TCP. Okay, so this is nice. Let's see where those actual packets come from. So I'm going to put the source and the destination IP parameters in it, and I'm going to remove the subtotals because they're not really needed for us. So now we can see a lot of communication, certain IP addresses. Now, what we really want to focus on is the TCP and the UDP. The other are typical network management protocols, so let me turn them off one by one. And here we go, the TCP and the UDP packets. Now, in TCP, what you see is one IP address is talking to the other, and then in response, the other one talks back. Now, you remember I plugged in the card and I only transferred one direction, and I still had communication both ways. This is a unicast communication, TCP, that goes between the two IP addresses, and the network was confirming the other way that it got the packages. So we did send a lot of packet in one way, but the other way confirmed because it's a connection-based protocol. However, in UDP, what we see is one device, which is the Vinx encoder, is talking. A lot of these data was sent into the 225203 address, which is a multicast group address. This is something we talked about in part 2 and 3. Now, 2252 is configurable. 03 is the video stream ID. So now you can see that the Vinx pairs are actually set into video stream ID number 3. If you would actually see in this screen more of these multicast groups, so different numbers, then you would immediately recognize that something's not right. If I have a pair of Vinx devices and they only communicate on this ID 3, I don't want to see an ID 1, 2, or 4 at the other video streams. So if you take this little table and you actually send it to the support team, then they would be actually able to help you a lot faster to see what's going on. Now I'm going to actually turn on a couple of port numbers. I'm going to also remove the subtotals. So what we're going to see here is a number of port source and destination port number pairs from the encoder and back from the decoder. So this is what I mentioned in part 1 and also part 2. There's different applications, different functions are running in the background. We have multiple network communications going. Now, you can see in this table that there is a specific high number here and also a high number down here. And this is, of course, a summary. So let's see what actually happens with those packages, what happens on those port numbers. I'm going to put in the time parameter. And now I have the entire communication that you've seen in graphic broken down to every second. So we know exactly how many bytes of data was going between the two devices. Now, in order to make this presentation a little better, I'm going to actually put this value and insert it as a text value into this table. And let's go to the end of this chart in the bottom and insert a line graph. Now, this line graph suddenly shows you these big spikes of communication. So this is actually what you've seen in the Wireshark bar graphs. This is exactly the same thing. So something large, and there was an interesting spike when I was cycling through the audio. There were some small spikes. Those were the TCP recognition of the SD card. Then I did the file transfer. And then down here is the video signal, which was, for the sake of this presentation, reduced by size. Okay, so this is summary. I've seen this, but let's understand what's going on. So if I grab this and start moving it to different ports, for example, on this particular port, there's some interesting thing going on. There are a couple of 100 bytes per second. These are a number of management communication between the devices. They're talking to each other, recognizing each other's communication channels and so on. What we really want to be interested in is the two ports that are big. Now, in this particular, the 59300 port is actually the audio channel. So this is where the audio signals, the guitar sound was going on. And as you heard when I cycled through the device, the sound cut off. So whenever the audio channel, in this case, the analog audio input was activated, the device recognized that if we want to send audio signal, and it started sending network packages to the other side, even though there was no actual sound from the guitar. And I turned on, it was no actual difference because the device recognized that we need to send audio signals and it started delivering the packages. there was no audio connection before, so the device did not use the bandwidth for that particular communication. And the other thing was, of course, the video signal. And this is what you see is why I don't enable the jumbo frame for the capture. So we see this nice shape of the actual video stream communicating. So we had some initial screen, and actually we had the full communication going on. And I started moving around the mouse. So when these little spikes, you can see I plugged the device, it communicated, it did the EDID communication, it recognized the screen, did an initial load. When I started moving the mouse around, the data started going and higher. So that plateau you see is me moving the computer mouse and changing information on the video screen. So this is actually how you can recognize these details. Now, one more thing, of course, we're going to look at just a little bit at the TCP communication. So from the decoder to the encoder, this is actually when we sent the files. We have a spike here because this is when I plugged in the card, and there's some communication to recognize the device. Then I had this large spike. This is actually the file transfer. And then I disconnected and the communication was broken. This is actually handshake, and those devices were talking to each other. And on the other direction, we have smaller data, but the similar spikes, because it's a two-way communication and it requires a connection between the devices. So they're confirming to each other that they received the packet. This is something you did not see in the UDP packets. In fact, there is no video and audio port in the decoder. It's not talking back because the UDP protocol is connectionless. It does not need to actually confirm that it's receiving something. And that's why we can actually do multicast. So this is actually the way how we can create an Excel table, look into the video signals, and we actually easily understand how the communication goes between devices. Now, if we create a table like this, I'm going to show you these numbers. Again, I'm going to take the time parameter out, and we're going to enable all the protocols. If you, let's say, would like to analyze network communication in a Wings product, then if you have a question and you would like to have a support from our support team, imagine if you create a table like this with all the ports, all the protocols, and all the IP addresses, and you send us a screen capture to our support team. They will be immediately seeing the details that are going on the network. And if there's unnecessary information like another Wings product, some multicast group information coming in, or we see 000 IP address talking in the source, which is probably a router is trying to do some IGMP querying, or I see an IGMP v3, which is IGMP querying again, then they can immediately say, wait a minute, there's a router on a device, or maybe IGMP snooping is not enabled on a port properly because there is cross communication. Now, I did an actual test here, and I was able to put about 2.5% to 3% extra details on the network communication just by putting an extra pair of Wings on it. And I did not set up the IGMP parameters properly just to see how much data I'm putting on with my own products, with the Wings products. So in this case, 2.5% does matter if we have almost the 1 gigabit Ethernet limitation. When we're close to it, then now we need to find out what is unnecessary in our network. So if you do this, and if you play around with this a little bit, remember Wireshark is free to download, and Microsoft Excel is something that, or other types of similar table applications are available most likely in your computer already. You can do this on your own anytime. You can play around with it. And with this, you can actually make network communication like tangible. So you can play around with it, you can have it in your hands, and you can actually learn and understand how network communication goes. What are those port numbers, how the multicast group communication versus a TCP stream going. And it hopefully kind of changes the purple cloud of confusion to a clear understanding of what IP communication is about and how does it affect the AV over IP products. And with this, we're at the end of our demonstration. I'd like to give the word back to Tibor. Let's see if you have questions.
Not yet, as usual. I guess this was also a lot of information, but this is when usually people start typing. So grab those keyboards while Gabor is here and he can answer your questions. All right, until questions start arriving. All right, we have a question. Are there any plans to have a feature like the Wireshark capture in Wings? Interesting question.
Well, it's an interesting question. Let me tell you what is required for us to do this. Wings is a rather easy thing because it's only gigabit Ethernet. We have a HP Z4 workstation, which is a industrial commercial level powerhouse workstation to do this. Next week, we're going to do UBEX, and then we're not going to be able to do this because we're going to capture millions of packets in 10-15 seconds. So in order to do something like this, you need a very high power, a big processor, and need large memory, because you need to do a lot of these captures. In fact, I had to disable a number of functionalities in Wireshark, so we would not overload and we would not create a giant file. A file capture like this is about 20 to 30 megabytes if I have all the details. And in UBEX next week, if I would try to do this, I would generate a 150 to 200 megabyte capture file in 10 seconds. So that's the processing power you would need to do this. And we have access to this from courtesy of HP EMEA of the Z4 workstation. That's why we're able to do that. But this kind of functionality really needs a lot of processing power.
All right. Someone had an audio issue. I hope it was fixed. The sound was good on my side, so at least the recording will definitely have good sound. So if there were audio issues during the webinar, then the recording will probably have good audio, so you can watch it back. All right. We finished early, thankfully. So I'll start wrapping up, and if we have any questions, then I'll read those. So thank you very much for joining this fourth session. I see the core, the hardcore people are here, who weren't frightened by the first three parts. So kudos to everybody who is here and who listened until the end. We hope to see you in the fifth part as well. When the webinar ends, you will be prompted to fill out a survey. If you have a minute to spare, we would really appreciate it if you gave us your feedback, what you liked, what you disliked, how you would like to improve this material. If you have any ideas, they are always welcome. So somebody wrote, I was frightened, but I'm sticking with it. ... Still frightened.
We'll try to make this.
We know the feeling.
Yes, we know the feeling of learning these things. It took me a lot of time to learn, and yes, it is confusing in the beginning, but it doesn't matter who tries to learn it. It takes time.
All right. So if you don't have any questions right now, you can send any questions in an email using training@lightware.com or support@lightware.com, and we will be happy to answer it or answer any questions. And unfortunately, these are not good times because of this coronavirus situation. So we cannot invite you to our offices, and we cannot go to your offices to do a demo. But we can certainly send you demo units, either Wings or UBEX. So if you would like to play around, try some things that Gabor has showed you, then please feel free to reach out to your local Lightware representative, and we can organize a demo unit. And you can play around with it for a few weeks, get to know it, and decide whether you want to use it in your future products or not. If you have any feedback, either positive or negative about the products, we welcome those as well. So we can always change the software or the firmware or even the hardware based on user needs. All right, I think that's it. I don't see any new questions, just a few thank you messages. So thank you, Gabor, for doing this fourth part. Yeah, go ahead.
Thank you, Tibor. Sorry for the interruption. I just wanted to add one more thing. If you're new to the Wireshark, I haven't seen you before, and you need help for setting it up in a way that I set it up, then just drop us a request in the same email that Tibor mentioned, and I'm going to help you set up the Wireshark software.
Yeah, absolutely. All right, so thanks everyone again. We hope to see you in the 5th part. And until then, stay safe. Bye.
Bye.